Welcome back. Definite integral 0 to 1 e to the x over 1 plus e to the 2x. Now this is a bit tricky. It takes some looking at it for some time to recognize. Let u equals e to the x. Then derivative of u is also e to the x. That's the top. So du equals e to the x dx or dx equals du over e to the x. Now let's worry about the limits of integration. When x is 0, u is e to the 0, that's 1, right? All we are doing is substituting in the expression for u. When x is 1, u is e to the 1, that is simply e. So the limits of integration have changed. 0 becomes 1, 1 becomes e to the x I don't know what to do with, but u is e to the x, so e to the 2x is u to the second power. Dx on the other hand is du over e to the x, and they cancel. So this integral, now notice all presence of x is gone. You have antiderivative or the definite integral 1 to e du over 1 plus u squared, that is arctan. Arctan of u, upper limit e, lower limit 1. Apply arctan of e minus arctan of 1. We know arctan of 1 is pi over 4, and that's your final answer here. A small piece of theory from geometry, it's very beautiful. A function f is defined on a closed interval negative a to a. It's said to be even if when you replace x by negative x, so f of negative x equals fx, so there is no change. On the other hand, a function f is defined on negative a to a is said to be odd when you replace x by negative x, negative comes out. F of negative x is negative fx for every x. Now, what happens to the symmetric functions? You see, if f is even, then its graph is symmetric about the y-axis. So if I take antiderivative or definite integral from negative a to a, there is equal amount on the right as on the left. So definite integral negative a to a fx dx is twice 0 to a. Twice definite integral 0 to a fx dx. This happens if f is even, because graph of an even function is symmetric about the y-axis. What about odd function? Graph of an odd function is symmetric about the origin. What that means is you reflect the right hand part once and then reflect it again. That is, take the right hand part, reflect it about y-axis, and then reflect it about x-axis. You match the other side. Notice in this case, the exact amount that is below x-axis is also above x-axis over negative a to a. Okay, in other words, these two areas cancel each other. So definite integral negative a to a fx dx is 0. So two consequences. For an even function, you have to take twice 0 to a. For an odd function, definite integral negative a to a is simply 0. It has a very beautiful consequence somewhere here. Notice, definite integral negative pi over 2 to pi over 2 x to the 4th sine x dx. Now you see, there is a product. We don't have a product rule. Finding its antiderivative could be quite a bit of work. We will need more techniques. Right now we don't. But What can we say about this function? Let me plug in negative x. F of negative x is negative x to the power 4 sine of negative x. Negative to the power 4 is positive, but sine of negative x comes out. So overall, negative survives. So f of negative x is negative fx. This means f is an odd function. In other words, definite integral negative pi over 2 to pi over 2 of my function f is 0. You notice how I didn't have to calculate anything. Simply because it's an odd function, as long as the limits are symmetrically opposite, its integral will be 0. How do we integrate something like this? Substitution. Call x plus 5u. Du dx is derivative of x, that's 1. So du is simply dx. Whenever you get du equals dx, it's called change of variable. So integral x square root x plus 5 dx is integral x square root u. X plus 5 is u. Now on the other hand, dx is du. Now what do I do with this x that was left over? Whenever something is left over, you go back to your substitution and see whether you can do better. U is x plus 5, so x is u minus 5. So that x becomes u minus 5. Square root u is square root u. Du is du. That's your original question. That is your intermediate stage. That is your present stage. Square root u is u to the power half. Distribute u to the power half. You see, you get u to the 3 halves minus 5u to the halves. Integral of this difference du. Power rule, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. 3 halves plus 1 is 5 halves. Half plus 1 is 3 halves. Division by fraction is multiplication by reciprocal. How did this become 10? There was already a 5. You multiply by 2 to make it 10. Finally, u was x plus 5. So I replaced u by x plus 5. Because this is indefinite integral, that is no limits are mentioned, you need to add plus c. A similar question, integral x square root of 3x plus 5. Well, same story, same approach. Call 3x plus 5u. Then derivative of u is simply 3. So du is 3 dx, cross multiplying. Dx is du over 3. U is 3x plus 5. So notice that x is still over there. So u minus 5 is 3x. Divide by 3, it's x. So you see, this way, we know this dx was going to be left alone. We somehow managed to get it written in terms of u. So x is u minus 5 over 3. Square root of 3x plus 1 is square root u. Dx is du over 3. Get things together. 3 times 3 is 9 in the denominator. We got it out. U minus 5 is inside. Square root u is u to the half. Du is du. Just as in the previous problem, distribute. U times u to the half is u to the 3 halves. 5 times u to the half is 5u to the half. Antiderivative, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Division by fraction is multiplication by reciprocal. So notice again 5 and 2, 10. Essentially the same problem, small change. 1, 9, 2, do not forget to resubstitute. 2 times 3x plus 5 power 5 halves over 5 minus 10 times 3x plus 5 power 3 halves over 3, and this is an indefinite integral. Do not forget to add c. Here is yet another question. Integral x square root of x squared plus 5 dx. Call x squared plus 5 u. Then derivative of u is 2x. That is du is 2x dx. In other words, dx is du over 2. So I did not bring the x down because of that x. You could have brought it down and cancelled it or left it. That's fine. So your original question now changes. X squared plus 5, let's get that, is u. This x dx, x dx is du over 2. Okay? Get the 2 outside, u to the half du. In antiderivative is u to the 3 halves over 3 halves. 2 times 3 halves is a 3. You have u to the 3 halves plus c. Replace u by x squared plus 5. That's your final answer. Okay. Try one more question. Integral x square root 4x squared plus 7 dx. Same story. Call that u. U equals 4x squared plus 7. Derivative of u is 8x. Du is 8x dx. So x dx is du over 8. X dx is du over 8. So our integral x square root 4x squared plus 7 dx is integral square root of u x dx is du over 8. Get the 8 out in the denominator. We just saw integral of u to the half du, u to the 3 halves over 3 halves. This reduces, notice. 2 goes here 4 times. 4 times 3 is a 12. You have resubstituted u to be 4x squared plus 7 to the power 3 halves plus 2. There are two more questions. I'll continue in the next video.